Nowadays, people are constantly on the move. And being on the go means that money is likely to change hands in the course of their travels. Physicist Dirk Brockmann researches the routes traveled by people and their money. He's interested in all forms of global mobility, which is why he follows the trails of banknotes. They provide data about how and where people travel, the key to revealing routes for infectious agents as they spread through a population. Brockmann and his colleagues are developing a mathematical model for the complex travel routes people follow. This requires a vast amount of information about where, how far, and how often they're on the move. The team was originally inspired by a popular internet currency tracking game called Where's George? In the game, people in the US report online where they have received one of many registered banknotes. This process allowed the researchers in Göttingen to follow almost 500,000 $1 bills.
What you can see here are the routes of individual bills, shown here in blue, for example. These started out in Seattle in the state of Washington, and then resurfaced less than a week later in other locations, represented by these lines. The yellow lines are the notes that started out in New York, and then reappeared a week later in California, for example. These are very representative routes for just a few of these bills. But now we have so much data that we can say very precisely how frequently certain routes are travelled by notes, and clearly that provides a reliable indication for the routes people tend to travel.
Even so, predicting routes is far from straightforward, just like the movements of this double pendulum. Although its movements appear chaotic, they can be described using relatively simple mathematical equations. And it seems the same applies to the various routes traveled by populations. That's what the Göttingen researchers concluded after weeks of calculations and discussions. Their model also demonstrates the difference between how viruses and other pathogens spread today compared to how they spread in the past. In the Middle Ages, for example, the plague spread slowly, in waves. But now viruses can flare up in one place and a few days later, hundreds if not thousands of kilometers away. It can take just weeks for a virus to spread around the world. On the left is the old pattern, on the right, the modern pattern.
When you attempt to simulate the spread of a flu virus, for example, then you obviously have to bear in mind that these viruses can mutate relatively quickly. There are additional mechanisms that vary from virus to virus, which need to be carefully treated according to the nature of the various epidemics.
This is the latest challenge for Brockmann and his colleagues. In order to create a detailed model for the spread of contagious diseases, they need to include a number of other factors as well, not just human travel patterns. One of these factors is the speed at which a virus can be transmitted. Another is how long it takes for symptoms to appear.
We intend to concentrate on what applies to many different viruses. If we can come up with some widely applicable conclusions, we may be able to use them to develop widely applicable preventative measures. And that's basically what our goal is.
More and more people are hitting the road, as tourists to exotic destinations or as migrants moving from continent to continent. The model depicting the travel routes of banknotes allows Dirk Brockmann and his colleagues to compile realistic descriptions of the routes taken by populations, and therefore also of the spread of dangerous viruses. Being able to predict which regions are likely to be hit first could help save lives.